This is part 3 of Qudieo number 1 AP Stats. Now we are going to do the AP question on the back and our last one. So the AP question says, as a part of the United States Department of Agriculture's super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites, River X, River Y, and River Z, have become contaminated with the pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentrate of alderin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plot shown below displays the 5 number summaries for the concentrations in parts per million ppm of alderin for the 20 locations that were sampled in each of the 3 rivers. So as we see, those are the 3 rivers that they're talking about, and they have provided us with box plots to show their data. The first question we have is compare the distributions for the concentrates of alderin among these 3 rivers. So the first thing that I wanted to do was describe each of the box plots so I know what I'm going to be comparing. So one of the first things you see is the medians, and obviously this median is the largest and that one is the lowest. And then I also looked at the shapes of them. So this one's skewed right, as you can see the median's right here, so it's going to be going to the right. This one is approximately normal, as the median is in the middle of the plot, and this one is slightly skewed left, as you can see, go that way. I also looked at the range, and so this one's 3 to 9, 3 to 6.5, and 3 to 5. So this one has the smallest range and the largest range. And then we also know there are no outliers, because in box plots, outliers are little dots, and as we can see in this, there are no dots in our box plots. Going into our description of the distributions, we want to start off with our context because that's what we need. So I restated what they had given us. The United States Department of Agriculture Super Dump Cleanup has 3 targeted sites. River X, that has the largest range of 3 to 9, which we had just seen there. River Y, that is approximately normal with a range of 3 to 6.5. and River Z with the smallest range of 3 to 5. So in the beginning, I just wanted to say the ranges so you can have an idea of the shapes of each one. In the data set, measures of contaminations of alderin, so I wanted to include a little bit more more context of what we're talking about. 20 randomly selected locations in each river were measured of the concentrations in parts per million, so we know what our data is and how much. River X has the highest median of alderin at about 5.2 ppm. River Y's median falls close behind at 5 ppm. River Z has the lowest median at about 4.4 ppm. So our median is very important when we're looking at the center of the data. So that is just an average of where we think that they are. So I made sure to include that. And then in the alderin measurements, a part of these 3 rivers, none of them had any outliers part of that data, which we had just looked at with the no dots. So we wanted to make sure that we know that none of them are outliers, they're all averages. River X is skewed right, meaning the mean of the measurements is greater than the median, which is approximately 5.2 ppm, which is important to notice because it is the only one approximately normal. And that's also going to tell us the mean of the data is about 5.2, and then the other ones we don't know what it is because they are both skewed right and skewed left. River Y, which is approximately normal, is equal in the median and the mean about 5.5 ppm, which is what we were talking about. River Z is skewed left, and in this data the mean is smaller than the median of about 4.4 ppm, which we know because in skewed left data the median is going to be larger than the mean, and in skewed right the median is going to be smaller than the mean. So that's all for the box plots of describing and comparing the distributions. Now we go to B, which tells us the 20 concentrates of aldrin of Rx are given below, and it gives us all the numbers, which is going to be this one right here, the largest range. And it asked us to construct a stem plot that displays the concentrations of aldrin for river X. So a stem plot is right here. So we're going to put the first numbers and then all the following of the counts. So we make sure we have our key. So the 3 and the 4 means 3.4 ppm of aldrin. So it's not 34, it's 3.4. And the only reason we'll know that is if you have your key. So the key is the key to making stem plots. So I went through all of these datas and put them into the stem plot. As you can see, there's a gap in between the 6, and then all the rest follow. It asks us to describe a characteristics of the description of aldrin concentrates in river X that cannot be seen in the stem plot. Oh, that can be seen in the stem plot, but cannot be seen in the box plot. So something we can't see in here, but we can see in here. So starting off, using the stem plot to show the distribution of aldrin concentrates in river X, we were able to see more precise amounts. So I wanted to make sure we knew what we were talking about by adding a little bit of context, but I also started off with what we can see, which is our precise amounts. So in here, we can't see the data individuals that we can here. We don't see each one of these numbers in here, we just see the shape of the data. So that's what I'm going to put by precise amounts, is we actually see them. From this plot of data, it is understood the minimum is exactly 3.4 ppm and the maximum is exactly 8.7 ppm, which is what we see by the 3.4 and the 8.7, and we can actually see that in here. Where in here, you can't exactly tell if it's like 3.2, 3.3, you don't really know, or right here with the 8. But in here, we can see the precise amount that it is. Also, from this distribution of river X's concentrates, the precise mean of 5.67 ppm and the standard deviation of 1.6745 can be calculated. The only reason we can calculate them is because we have all the precise amounts. Within this box plot, we're not able to see those, and we can't calculate them because we don't have the data and visuals. But in this one, we can. So in here, you can actually know the standard deviation and the actual mean. Using the stem plot, we were able to see the data individuals, whereas in box plots you can't, which is what I've been talking about this whole time, where you can see the numbers, but in here you only see the shapes and the median. You can see the 5-number summary of the quarter 1 and the minimum, but you can't exactly see the precise amounts where you can in here. Hope you learned what you don't know now. Good luck on your AP exam, and have a nice life.